Find the value f of x for x equals 2.8. In this problem, 3 triangular fuzzy-based if-then rules are provided, where the dashed line of each color represents the premise, and the solid line of each color represents the consequence. For this problem, we'll use mean defuzzification to develop a response curve f of x. Defuzzification is the process of producing a quantifiable result when provided fuzzy sets and corresponding degrees of membership, or fulfillment. Defuzzification by the mean value means the fuzzy response f of x is equal to the sum of the degree of fulfillment of the fuzzy premise argument, which is a function of x, multiplied by the mean consequence for each rule I, divided by the sum of the fuzzy premise degree of fulfillment for each rule I. If there are 0 rules where the degree of fulfillment in the premise clause is greater than 0, then the function f of x is undefined. If there is only one rule where the degree of fulfillment in the premise clause is greater than 0, then the degree of fulfillment terms cancel out, and the function is simply the mean consequence for that rule, mb of I, and the function f of x for this x value is degenerate. If there are 2 or more premise clauses whose degree of fulfillment is greater than 0 for a given value x, then the function f of x is complete and non-degenerate. Therefore, we only want to evaluate the function f of x for the range of x where the corresponding premise values of 2 or more rules are positive. This corresponds to the values of x between 1 and 5. Within this range, the defuzzified response f of x follows a unique curve for different subranges of x. These subranges are delineated by change in any one of the fuzzy premise functions, mu ai of x. For the first premise, 1, 2, 3, t, the slope changes occur at 1, 2, and 3. For the second premise, 3, 4, 5, t, the slope changes occur at 3, 4, and 5. And for the third premise, 0, 3, 6, t, the slope changes occur at 0, 3, and 6. When combining these slope changes, we'll evaluate f of x for x ranging from 1 to 2, 2 to 3, 3 to 4, and 4 to 5. To aid in this calculation, it is convenient to define the fuzzy degree of fulfillment for each non-degenerate range of x values for each rule I. If we begin in the first range, where x is at least 1 and at most 2, the degree of fulfillment for premise 1, 2, 3, t equals x minus 1. The degree of fulfillment for fuzzy number 3, 4, 5, t in this range equals 0. And the degree of fulfillment for fuzzy number 0, 3, 6, t in this range equals 0.333 times x. Next, the degrees of fulfillment for the second range, where x is at least 2 and at most 3, are evaluated. This time, the degree of fulfillment for the first rule evaluates to 3 minus x, and the second and third rules remain the same as the previous range.